Greetings everybody, greetings from the Hannover Messe 2025. We are in AWS booth and we're talking to a couple of folks, John Harrington from HighByte and Evan Kaplan from InfluxData. Welcome, we're talking about industrial data. Perhaps let's start a little bit with manufacturing generate a lot of data. What are some of the enablers that turning that raw data into real insights? Maybe anybody wants to comment on that?
Be a good one for you to start with.
Yeah, thanks, Lucian. It's great to talk to you. What we're seeing is people are collecting large volumes of data. They're putting it, and they're collecting it not only within a single site, but across multiple sites, and they're putting it in data stores. The challenge is if you're going to do that, you need to add context to that data, because you need to, separate out where it's from. You need to identify what machine it's from, what line it's on, what facility it's out of. So adding that context has become a really important thing as we're collecting all this data, so that we don't have data swamps, so that we have usable data that the teams can work with. So being able to do that has become really critical.
Thank you, John. Now, both Influx and HighByte play a critical role for industrial organizations to handle operations data at scale. From your vantage points, what fundamentally changing and how manufacturing and industrial companies think about the data, especially intersection of OT and IT?
So I'll take this one.
Go ahead.
Yeah, it's I think probably the most interesting change is most of what manufacturers have done with their data sets is about monitoring. It's really about monitoring systems in time, paying attention to them, seeing how they're running, collecting the data. And monitoring generates a lot of data, right? And depending on your resolution, you can go anywhere from 30 milliseconds to a millisecond to a minute, depending on your resolution, depending on what kind of equipment you're running. But what really I think is interesting, particularly as we think about this next generation of intelligence that's being created from the data, is control. Is the idea that the data that you're creating is more than just passive data, but now you can start building more sophisticated control systems. And you can see we're here at Hannover Messe. You can see how many robots are on. This is just the very beginning of a cycle of building more sophisticated control systems. And from our point of view, that's much more about real time. That's really about super fast resolution. It's about querying. It's about taking action on the data. I think that'll describe the next 10 years of manufacturing intelligence.
Thank you, John. Anything you want to add? Or?
Yeah, I think there's a control piece, but it's not just control for the process. It's control of the process, but it could be for quality, or it could be for sustainability, or it could be for maintenance purposes. And there's a control lever for each one of those as well. And so it's really bringing those. In the past, it was all about just keeping the line running. And now what we're seeing is how do we optimize the line for not just running and creating product, but making sure that the high quality, high yield, it's always running. So there's a much more diversity of disciplines that we're bringing into the mix. And I agree, it's all about making sure that we can optimize.
Thanks, John and Evan. Now, you've touched a little bit on the controls and changes there. Now, maybe what are some of the biggest architectural shifts and you're seeing in IoT right now, and how are the platforms helping companies adapt?
It's I would think, and you're a little bit closer to the manufacturing floor than I am, but it's tectonic. There's no customer that we're talking to that hasn't built either a lakehouse or a big data architecture, who's not working on machine learning models, who's not taking their data and creating intelligence. And so, I think the role, and John, I don't want to step ahead, but I think the role that both John and I play, us on the collection and action side, and you and on the enrichment side, is about how do you take the raw data that's coming off of all of this sensor, all of this monitoring data, and turn it into intelligence. And the brilliant work that's being done is where IT hits OT is in the IT side, in let's call it data engineering and creating intelligence from the data. And I've seen, depending on the industry, from the least sophisticated manufacturing industries to the most, is just this thread going through all the way through, where people are really working hard to figure out. And you hear the words like predictive maintenance. Predictive maintenance is just the beginning of that journey of building these intelligent systems that are increasingly autonomous.
Thank you.
Yeah, it really, we're seeing the same thing. We're seeing new analytic approaches. Now, we're still seeing some companies have just never had access to the data, but then they want to layer on, because there's so much data, we need to layer on machine learning, we need to layer on AI, and then, LLMs, and then agentic, and it's just increasing the need for data. All of that AI and all of those different techniques need data, and so it just becomes so critical to be able to store it and to be able to enrich it and to be able to deliver it to wherever it needs to be.
One way to think about all of this is, we talk about in manufacturing world, we talk about digital twins. The truth is, the world is increasingly digital first, and their physical twins are the right way to think about this. Is you model all of your stuff on the data plane, and then you build hardware. That's increasingly how these systems will be built. Because once you understand what the data flows are, you can match it to the hardware longer term, and that's a flip on the whole industry. And I'm not saying it's happening tomorrow, but it's happening.
Thank you both. And now, too often, time series is treated just like another data stream. What are manufacturing missing out, and when they fail to recognize its unique characteristic and potential? Maybe, Evan, you want to take that?
Yes, since we're the time series people. Let's start with the highest thing. All human design systems want to be increasingly autonomous. They want to be self-correcting, they want to be self-healing, and eventually they want to be autonomous. In time series, it's really simply about what happened, what's going to happen. It's about instrumenting the physical world, sensors, at high degrees. We have customers who use nanosecond resolution for some. Think about that. It's about instrumenting what's going to happen in the physical world, and so if you think about control systems and you think about autonomy, time series is the oil and gas of that revolution.
Right.
So I'm biased, right? We make a time series database, so we think time series is the whole world.
No.
Well, I think what we see is the time series telemetry is critical. It's really critical to every use case. However, you contextualize time series data based on the application that's used for the domain that you're trying to contextualize on. So for instance, if you're doing production analysis, then you would contextualize it with MES data. If you're doing predictive maintenance, you may contextualize that data with the maintenance system, the CMMS system. If you're doing quality, you need to contextualize it with the quality system data. So what we're seeing is the merger of all these different systems. And if you look at a factory floor, there's most factories, it's not just a single MES system, it's not just a single SCADA system or a single historian. There's lots of different data systems. So sensor data is critical, the telemetry data, but then there's a lot of other data that we need to bring together in order to solve these problems and to contextualize them.
So one easy way to think about it, because you have the two vendors up here, is these guys are a refinery. They're part of the refinery. It's how do you take the raw data that we're creating at super fast speed, right, and turn that into increasing intelligence, right? So equivalent to how do I take the oil and gas out of the ground and then turn it into products that can be delivered to the real world, right? It's a good way to think about this whole thing is how do you get that, how do you collect that meaningful data, and then how do you turn it into something that's intelligent and actionable?
Right. So I'm curious.
Some of that, but they do a lot of it.
Right. So switching the conversation a little bit to the edge, I'm curious if you have any numbers. What are you hearing from your customers? How much of that data is processed at the edge? And then maybe talking about, what are some of the design principles that industrial leaders should adopt to be more resilient and distributed systems to be for the future?
So for us, the edge is obviously critical.
Right.
If your system's going to operate in real time, right, and you're going to feed that data, then things have to be at the edge. So you can imagine the factory floor. You imagine a lot of industries. It's very common to have a 3-tier architecture, which is intelligence at the edge, cloud, and a cloud basic to build your sophisticated models. This is where the lake houses come in. This is where the enrichment of data comes in. But if you don't have for many applications, not all applications, the edge is an absolute requirement.
Thank you.
Yeah, we're seeing people using data at the edge, data at the data center, data in the cloud. The other challenge that you have is, in some cases, you need exceptionally high resolution data, the millisecond or even nanosecond level. But you don't need that for everything.
Right.
And if you can't discriminate what you need, the high resolution, what you need, the low resolution, then you have too much data. So given the amount of data that's actually created in the factory, we need to be able to discriminate. And many times it's discriminating based on how we're using the data. Are we doing high-end predictive maintenance on power quality, in which case we need millisecond or even faster data? Or are we just looking for some signals on we're creating a number of defects and our line is only putting out product every minute, so we don't need to collect it all that frequently. So there's lots of different use cases, and each one of those has different needs for data, different contextualizations of data, and different frequencies of collecting it. So being able to discriminate that is critical, or else we have either too much data or we don't have enough. And that's what we have to prevent.
Thank you both. And if you are in the audience, you have questions for John or Evan, feel free to leverage the hashtag on the screen.
Thanks, Lucian.
Thank you.